All right, today we are starting section 7.3. We are going to use what we call the angle postulate. Again, this is going to seem kind of familiar because it is kind of like when we did congruent triangles. But in this chapter, we don't have congruent triangles. We have what kind of triangles? Similar triangles. So our postulates will sometimes look a little bit different because it's not to show congruence, just similarity. All right, I'll give you a couple minutes to work on your warm-ups. These are all equations that you should have been able to solve in Algebra 1. So I'll let you give those a try before we talk about them. All right, number 1. Who had an answer they wanted to share? Jakeem? I would agree with 11. You would have to add 8 and then divide by 3. So 11 sounds good to me. Anybody get an answer for number 2? Michelin? Equals negative what? 10. Okay, so you technically have 2 options to start this one. Most students distribute to start it off, which is one option. If you divided both sides by 4, that's the other option. Subtract 20 on both sides. 8x equals negative 80, then divide by 8. I would agree x equals negative 10. Questions, concerns on those first 2? Okay, anybody get an answer on number 3? Crescencio? X equals 4. Let's see. 1? Okay. So we would distribute, or I'll show the other way this time. You could divide both sides by a negative 5. That's another option. That would leave us with 3x minus 4 equals negative 7. Add 4 on both sides. I'm going to take away number 5 for just a minute. We would get 3x equals negative 3, then divide. And x equals negative 1. Anybody get an answer for number 4? Anybody that hasn't already told me an answer? Nobody did number 4 except somebody that's already talked to me? Okay, Michelin, what'd you get?
X equals negative 1.
Okay. Anybody else get that? They just didn't want to share? No sharing? Okay, let's see. So this one's a little bit longer. We have to distribute twice in the very beginning. Make sure you treat that negative 3 as a negative both times you distribute it. So we'd have minus 6x minus 15. You have like terms that are on the same side of the equal sign, so they can get combined, meaning the 5x and the negative 6x get combined to give me negative 1x. The positive 20 and the negative 15 combine to give me a positive 5. Questions, concerns so far? Okay. Then we would subtract 5 on both sides. Negative 1x equals 5. Divide by a negative 1. X equals negative 5. Anybody get negative 5 and they just didn't want to share it? If we did not get negative 5, do we see where we went wrong? How to fix it? I think the most common error is probably not treating that like a negative 3 both times it gets distributed. questions before I erase those to bring back number 5? Okay. And I'll just make it all disappear. On number 5, did anybody get an answer they want to share? What'd you get, Courtney?
2.5 repeating.
The 5's repeating?
Mm-hmm.
Okay. Anybody else? Okay, let's see. First thing I would do is distribute that -5. Again, it's a negative both times it gets distributed. On the other side of the equal sign, we could combine like terms. We've got a 12x and a -9x. Those combine to give me 3x, still -16. We need all of our x's to be on the same side of the equal sign. So you could either subtract the 3x on both sides, or you can add the 15x on both sides. I'm going to go with adding 15x, just because I like to keep things positive. But if you did it the other way, that's fine. 30 equals 18x minus 16. From here, I think everybody should be comfortable with it. Divide by 18. So I agree that'll give you a decimal. I'm fine with a reduced fraction. If you give me a decimal and you put the repeating bar on it, that's fine. You didn't round it or anything. If we were to just simplify this, divide top and bottom by 2, 23/9 would also be acceptable. Questions, concerns about number 5? We feel good about solving equations? Bringing back those algebra memories? Good times. Okay. We'll move into our notes then. The AA postulate, or angle-angle postulate, states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So you only need to know two pairs of congruent angles in order to have similarity between your triangles. Remember, similarity is not the same as congruence. A little different from each other, even though they have some things in common. So, for example, if we knew angle A was congruent to angle D, and we knew that angle C was congruent to angle F, then we would know that the triangles are similar. Two pairs of congruent angles. It does not matter which two pairs you have. So I could have used angles B and E instead of one of those other pairs. Alright, so for our first one, we are asking if the triangles must be similar. If they are, we write a similarity statement. So, I feel like this got written a little funny in here. This triangle should be closed at the bottom. Remember, your pictures don't have to be perfect. They should just be labeled the same way. From what they've shown us in these pictures, do we have two pairs of congruent angles? Just from what they've already written down for us. No, we've only got one pair from what they've shown us. Which pair do we already have? Okay, angles B and E were already marked congruent because they've got the same measure. So far, we don't know for sure that these are similar triangles because we only have one pair. So we need to see if we can show that we have a second pair, which means we should try to find the measure of at least angle C, maybe also angle D. How did you figure that out? Okay, so all three angles have to add up to 180. So if we subtract the angles that they gave us, we can see that angle C is 37 degrees. Now this is not looking promising, but to be completely sure, we could find the measure of angle D also. Good. So again, we subtract from 180. And we get that the last angle here is 73 degrees. So are these triangles going to be similar? No, because even though we found the unknown angles, we still don't have another pair. So they are not similar. If they are not similar, we don't write a similarity statement. Questions, concerns, need more time on example 1. Okay. Same question for example 2. This is an R up here. It kind of looks a little funny. The way that these are drawn for us right now, do we have any pairs of congruent angles between the triangles? No. They told us an angle of 36 and an angle of 72. So right now, we don't have any pairs. What's helpful is that they marked this triangle with one tick mark on each side. So what type of triangle is it? Thanks. Isosceles is correct. Some people were saying that. This is isosceles if you have two congruent sides. Same thing with the other one. Another isosceles triangle. We have to remember from first semester that we had a property of isosceles triangles that was told to us in the base angles theorem. It said that if you have an isosceles triangle, the angles across from those sides were congruent to each other. So these angles across from each other are congruent to each other within that triangle. Right now, that doesn't help us out too much for triangle RST, but for triangle MNP, it tells us that angle P measures 72 degrees. So we could fill that in, and then it would be easy for us to find angle M. How would we find angle M? 180 minus 72 and 72 again, so that would be 144. I got that by taking 72 plus 72. So angle M measures how much? Anybody? 36 degrees. Now that is helpful to us because now we have a pair of congruent angles. Is that enough for us to say that these are similar? No, we still need to get another pair. So we still need to figure out angle S or angle T, but really it'll be both. So, if we don't know something, what do we usually put in its place? An X or some other variable. And if these have to be the same, I'm going to give them both an X. Then I could set up an equation to solve for X. What would that equation be?
X plus 36 equals 100.
So X plus 36 equals 100.
Good. Bella's got it. We got to use both of the X's. So you could put X plus 36, but that's really the same as 2X plus 36 equals 180. You don't necessarily have to do this algebraically. You could have just kind of reasoned your way through it. But I think the algebra helps some people. To solve this, we're trying to get X alone. What do we end up with for X?
Well, wait, no.
72. So now, do we have enough information to say that these triangles are similar? Yes. We actually have all three pairs of congruent angles, even though we only need 2 pairs. That's fine. Before we write our similarity statement, do we have questions about finding the angles? Okay. Remember when we make statements about similarity or congruence, we get to pick how we name our first triangle, and then the second one depends on the first one. So how do you want to name your first triangle? Okay, we could name it SRT, which means the second one would have to be named how? NMP. Technically, in this case, S and T could get swapped, and N and P could get swapped, and it would still be fine. But angles R and M better match up no matter how you make your statements. Questions, concerns? Need more time? Moving right along. Must the triangles be similar? If so, write a similarity statement. Same directions, different diagram. This is supposed to be angle B down here. Make that a little bigger. Off to the side, I'm going to draw the triangles separated. So if you want to do that as well, draw them together, but also show them separated. What's one of the triangles I'm looking at? Okay, ADE is that smaller one up in the top. What is the other triangle we're looking at? Okay, the big triangle ABC. Again, my triangles aren't perfect, but they work well enough. Alright, so from this diagram, they did not mark any of our angle measures for us. We don't really have any way of figuring out numbers to put into these angles. But some of these angles are already congruent to each other. Can anybody tell me which angle is congruent to which other angle by the reflexive property? Somebody said it. A. Angle A is congruent to angle A. Any angle is congruent to itself. An angle A we drew 2 times. One at the top of the small one, once at the top of the big one. So we already know that that angle is congruent to itself by the reflexive property. Now these little arrow marks they put on here, usually we kind of closed them in and made them little triangles. Does anybody remember what these stand for? Good, parallel lines. So parallel lines give us congruent angles when they are crossed by a transversal. So if we look at the parallel lines and we take this side AB as our transversal, what angle have I outlined from my top triangle? Which one? D, good. So ADE up here, or we could just say angle D. Whoop. That's going to be congruent to which angle from the other triangle? B, why? What's their relationship? Very good. They are corresponding angles on those parallel lines. So in the diagram, we see them as corresponding. Therefore, we know that they are congruent. Now, technically, you could do the same thing with angles E and C if you use the other transversal, but we don't really need to. In order to show similarity, we only need two pairs of congruent angles, and we have that. So we are ready to make our similarity statement. I'll do it off to the side here on the left. How do you want to name your first triangle? Okay, I heard DEA first. If you went different from that, that's fine. Just means your second one will also be different. So if we call the top triangle DEA, then the bigger triangle has to be BCA. Again, make sure you're only putting a congruence, sorry, not a congruence, a similarity symbol, not a congruent symbol. If you were to put the equal sign under this, that would be wrong. Questions about example 3? Okay, moving on. Use the diagram to find these measures. Then we are going to be asked if they are similar by the angle-angle similarity postulate. I'm guessing the answer will be yes, because then they ask us to find the length of CD. We get that diagram down? All right, first one's easy. What's the measure of angle ACB? 41 degrees, because those angles are vertical. So that one is easy to find. Vertical angles are congruent. Next, they ask for the measure of angle B. So again, we're going to take 180 minus 56 minus 41. What would we get? Good, we get 83 degrees for angle B. What do you think the measure of angle E is? It is 56 degrees. If you really needed to, you can show 180 minus 41 minus 83. It will give you 56. Are these triangles similar by angle-angle similarity? Yes, they are. Before we find CD, let's go ahead and make a similarity statement. I think that'll help us out with finding CD. How do you want to name your first triangle? Okay. And how do you want to name your second triangle? So we started with angle A. We've got to start with angle E. E is the other one that's 56 degrees. Okay, so we start with angle E. Then if B is in the middle, B was the 83. So D has to go in the middle here. And that leaves C for the end. Okay, so remember, these won't always go in alphabetical order the way we might want them to. Questions about our similarity statement? Okay. I am going to mark CD with an X since that's what we're trying to find now. We have to set up a proportion to do this. Remember, in similar triangles, your angles are congruent, your sides are proportional. So I need to be able to compare two sides that I already know. What two sides do I already know that I could compare? Let's see. So side AC would have to get compared to side EC, and I don't know EC. So remember, that's why we made our similarity statement, so you can match things up. AB and which one? ED. Okay. We know AB and ED, and from our similarity statement, we can see that they do correspond to each other. What is AB over ED? Okay. In our other proportion, we know we need to use side CD, which is X. Should that go in the top or the bottom? Anybody able to justify their answer?
What was the question?
Should the X that represents side CD go in the top or the bottom of my other ratio? Why?
Does it matter what the X was?
It does matter. So let's go back to our first ratio. This 8 that we put on top, which triangle did that come from? ABC. So on the top of my other ratio, I should be putting something from triangle ABC. Does X come from triangle ABC? No. So X better not go on the top. The 12 that we use came from the second triangle EDC. The X comes from there also, so the X needs to go on the bottom. So the last thing we need to fill in or figure out is what side from the first triangle corresponds to side CD, or in this case it's written as DC.
BC.
BC. And what is the length of BC?
10.
10. Questions about how we set up that ratio or that proportion? Okay. To solve it, we should cross multiply. 8x equals 120. Oop, not 180. Divide by 8. 15. Questions, concerns about any part of example 4? There was a lot to it. Anybody need more time on this slide? Okay, we'll keep it moving then. Is triangle XYZ similar to triangle RTS? If yes, write all other proportionality similarity proportions. I feel like they really mean similarity statements, which there would actually be a lot of them. So I'm going to change that a little bit. Similarity proportions are the ratios. I think they mean the similarity statements. All right. First thing we should be trying to figure out is the measure of angle Z. That one's not so bad. What is it? 90. If you take 180 minus 45, you would get 90. In the other triangle, we've got a 90-degree angle. What do we know about angles R and T? They're congruent to each other because it's an isosceles triangle. So if you take 180 minus the 90 you already have, and then split it into two congruent angles, each of them would measure 45 degrees. Questions about figuring out our missing angles? Okay, so they're asking, is triangle XYZ similar to triangle RTS? Yes, it is. That works. We've got congruent angles matched up with one another. We've got at least two pairs of congruent angles, which would make our triangles similar. So there's one similarity statement. What they asked us for was all the other similarity statements. So, let's keep it with triangle XYZ for now. Instead of going RTS, what could I do instead? Good. We can mix it up because we've got multiple 45-degree angles. Now, if we were to switch up how we named the first triangle, we could name it XZY instead. And we could say triangle XZY is similar to which other triangle? So we could do it a couple different ways. One way would be to do TSR. The other way, if it's still XZY, it would be similar to RST. Basically, anytime we make these, we have to make sure which two letters stay together or stay matched up. So what I mean by that is sometimes we matched angle X up with angle R. Sometimes we matched angle X up with angle T. But which two angles always stayed together, paired up? Which one? Good. Z and S had to stay matched up because we only had one 90-degree angle in each of them. So technically, I think we could continue mixing this around. Like if we didn't use X first, we could have made Z go first. We could have made Y go first. There are actually lots and lots and lots of similarity statements we could make. Questions, concerns about number 5? Okay. And I will get your homework for you.